Bismillahirrahmanirrahim. Assalamu alaikum students of class 8. Today we are going to start our new unit, that is unit number 8, physical and chemical change. So this is a section of chemistry in science. So we will be studying what is a chemical equation, how a reaction takes place, and how do we balance a chemical equation, the concept about a chemical equation today. So the chemical reactions are linked with a change. Whenever a change in the chemical makeup of any substance takes place, it is said that it is a chemical reaction. A chemical reaction is normally irreversible. It cannot be changed. If a chemical reaction takes place, it cannot be changed, and a new product is formed and developed out of it. It is non-reversible or irreversible, you can say. So what are the signs if a chemical reaction takes place? You may find out a change in color of a substance. You can also see that a gas is evolving after a reaction. You can judge that the temperature is increasing after the reaction, and you can also see that the state of the material is changing. That may be changing from solid to liquid, or maybe changing from liquid to gas. So these are the signs of that a chemical reaction is taking place. Otherwise, in normal reactions or in normal mixing where there is no chemical change, you may not find out the heating effect, the lightning effect, the change in the form of gas. For example, mixing salt and sugar, there's no chemical change and it is reversible. We can separate salt and sugar, but in a chemical change we cannot separate two materials after the reaction. Now the word equation. What is a word equation? A word equation describes a chemical change completely by using the proper names of that materials which are reacted. For an example, I want to write a word equation of two materials in which a methane gas is reacted with oxygen gas, methane with oxygen, to form carbon dioxide and water. So here you can see methane, methane properly is written. oxygen, oxygen is properly written. Carbon dioxide, what is properly written? So the materials written in complete words is known as a word equation. And chemically, how we write it, the formula of methane in chemistry is CH4, having one carbon and 3 hydrogen atoms, whereas the formula of oxygen is O2, having 2 oxygen atoms bound together forms an oxygen gas molecule that results in carbon dioxide. CO2 is the formula of carbon dioxide, and H2 the formula of water. So the red 2 you are seeing in the equation is digit added in the equation to balance the equation. The reactants, methane and oxygen, must have the same number of atoms of reactants and the same number of products. Both the reactants and products should have the same number of atoms in the equation. Otherwise, if not, then we balance that equation by putting a constant number on both sides. So then we satisfy a complete equation. Now the chemical equation. The simplest form of describing a reaction, a chemical reaction in short form, is known as a chemical equation, where the chemical symbols of that equation are mentioned, not the complete words. Mg stands for magnesium. O2 stands for oxygen. So magnesium and oxygen react to form MgO, magnesium oxide. So the reactants are magnesium plus O2 oxygen written on the left side, and the products are written on the right side. So this is known as a chemical equation, and the arrow in between shows the direction of the reaction. So this is a chemical equation. Now, characteristics of a chemical equation. How a chemical equation should look like, how a chemical equation should appear. The chemical equation should represent the facts. It must contain the correct formula of the reactant and the products. The formulas should not be mistaken. So it should fulfill the law of conservation of mass. That means that the number of atoms in on the left hand side should be equal to the number of atoms of the same element on the right hand side. Means the number of reactants, the atoms of the reactants on the left hand side should balance the number of atoms of the products on the right hand side. This is the law of conservation of mass. I will explain it to you in the next slide more clearly. For an example, the first step is showing phases. How can we show phases? H2O. H2O stands for water, and S in brackets is showing its solid form, solid phase. So it is rigid, and solid phase has a defined volume and shape. So for an example, sodium chloride. Sodium chloride is a salt. So as sodium chloride has a rigid shape, similarly water in solid form, that is ice most probably. Then the second one is the liquid phase. You can see L in the brackets. That has a definite volume and is able to change its shape and can be flown. Whereas gaseous phase, G in the bracket on the right hand side, is a substance that has no definite shape and volume and is in its highly reactive phase, the gaseous phase. So the S, L and G in brackets shows the phases of the chemical which we are using. Now, law of conservation of mass, that involves that the total mass number of the material or the chemical should be equal on both sides. For example, MgO, here you can see it's written MgO, magnesium oxide, is formulated on the product side. We were having 2 atoms of oxygen but 1 atom of magnesium. So what we did to balance the equation is we added 2 on with the magnesium and 2 with the magnesium oxide molecules. Now the magnesium is having two atoms on the left side, and two magnesium atoms are present on the right side, whereas O2 was a complete molecule of oxygen having two atoms bound together. So by adding 2 on the magnesium oxide product, we are also having two atoms of oxygen on the left side. So both sides have two atoms of magnesium and oxygen. So this is how we balance an equation, by adding a numerical or numeric to it. For further understanding, I want to show you a diagram that we reacted hydrogen with chlorine to form HCl, and you can see two diagrams. One, you can see a seesaw. On the left side we added two hydrogen atoms, two chlorine atoms. What we found? HCl. The HCl on the product side is not balanced, it's unbalanced, not having two molecules of chlorine, two atoms of chlorine, not having two atoms of hydrogen. So what we will do, moving on to the right hand side image, we added the digit 2 on the product side. Here you can see in the key where H2 and 2 on the product side, Cl2 on the reactant side, and Cl2 on the product side. How? By adding the digit 2 in the chemical equation that we added manually. Here you can see. So this is how we balance an equation.